Hello, I'm Neel Gopalan, Principal Engineer in Custom Compiler team. I will present Custom Compiler Quick Start Kits. These are process optimized solutions for FinFET technology nodes based on the experience of us working with Synopsys IP design teams. Now, what is a Quick Start Kit? We work closely with our mixed signal IP design team on all the FinFET technology nodes. For all technology nodes, there are three major components required for doing designs efficiently. These are tool-specific features in Custom Compiler, node-specific tool settings, and design methodologies that include flows and utilities. QSK augments the IPDK from Foundry to provide process optimized solutions that include these three pieces. Let me give an overview of our mixed signal IP team. We have 3,600 plus engineers working on building custom and analog IPs across the globe. These include IOs, analog, embedded memories, and logic libraries. Because these IPs should be ready when customers start designing, we are among the first to design on any new technology node. Hence, we discover the unique design challenges for a given node before other customers do. We build hundreds of IPs every year. Just in 2019, we have done 20 IPs on 5 nanometer node. These are complex IPs working at extremely high frequencies. The example here has a mix of analog, RF, digital, and mixed signal designs. Hence, the flow needs to cover all different types of IPs. The Quick Start Kit for each process node has methodologies and settings for all these IPs. Now, why do we need a QSK? For any new node, we hear the design time increases anywhere between 3 to 5x. These typically come from exponential increase in design rule complexity. With so many rules, it is impossible for designers to keep all these rules in their head. Designs often require multiple iterations due to parasitics and reliability issues. For example, our IP CAD head once told me that their layout is the new schematic as they do not know all the layout effects up front for the FinFET technology nodes. QSK helps accelerate custom design. The answer to layout complexity is visually assisted automation, which consists of device placement and routing automation. Designs also require layout finishing, which require decap and dummy cell insertion along with complex guard rings. Let me talk about some of the biggest challenges in device placement and routing. Due to restricted device size, one schematic device will result into hundreds of layout transistors. It is a cumbersome task to efficiently place these transistor arrays and complete the routing. What have we done in the QSK? QSK enables symbolic device placement with predefined matching patterns. QSK also provides process optimized track patterns for a variety of design types that are EM, R, and C friendly. Now that we have placed these transistor arrays, we need to bring transistor connections to the first metal for completing the routing. Transistor local interconnect utility helps with transistor connections and efficient track management. And finally, use the built-in router, which is a graphical catalog of common routing patterns to complete routing of FinFET arrays. After placement and routing of FinFET arrays, I need to create decap, dummy cells, and guard rings, as well as fill shapes for running DRC and LVS. This process is often time consuming and has to be repeated over and over for every design iteration. Hence, there is a need to automate this process. QSK provides utilities that automate dummy, decap, guard ring creation as well as fill shape generation. For running LVS, we automatically back annotate devices onto a schematic. So far, we saw how QSK helps in reducing design rule complexity for layout generation. Now, let me talk about how QSK helps with reducing design iterations. The answer to increase design iterations due to parasitics and reliability is to perform early electrical analysis. Checking for electromigration, resistance, and capacitance after the layout is complete leads to long iterations and often redesigning the entire block. We need electrically correct, not just electrically aware engines to catch these issues early on in the design cycle. It is good for layout designers to check EMRC while doing the layout. QSK provides mapping files and settings to check and fix design rule violations, electromigration, resistance, and capacitance on canvas. We use StarRC, Custom Sim Array, and IC Validator sign-off engines with Foundry release run sets. After talking to customers, we observe there is often a large difference between pre and post layout simulation, resulting in design closure delays. Traditionally, for RC and LDE extraction, I need LVS clean data. Typically, schematics have estimated parasitics, but analog designers need a way to rerun simulation using best available information from layout. QSK provides a flow for extracting accurate LDE and RC data for simulation based on partially completed layout. This flow uses sign-off run sets and engines very early in the design cycle to catch circuit performance issues through simulation by combining estimated and extracted parasitics. For more information on our IP team's experience in using this flow, please go to customcompiler.info. To summarize, custom compiler quick start kits are process optimized solutions to accelerate layout and reduce design iterations. QSK enables advanced node features, node specific tool settings, and design methodologies that include flows and utilities. Thank you. For more information, please visit customcompiler.info.